Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Nurfiana Rahma. You can call me Ika. And now I will presentation about types of colloids and their properties. What about different kinds of mixture? For example, we've learned about homogeneous mixture involving ionic or covalent solids. They disperse evenly in water or some other solvent to form a solution. We have also seen certain heterogeneous mixture where the compounds do not mix whatsoever, like oil and water. More often than not, a discussion of mixture will end there. But the reality is that there are other types of mixture that do not fall strictly into one of these extremes, but rather is in between. So let's find out what this could be. One such type of mixture is called a suspension. This is a heterogeneous mixture composed of large particles that are visible to the naked eye. An example of this can be generated by mixing mud and water. They will not remain completely separate like oil and water do, nor will things disperse perfectly evenly. Instead, there will simply be a cloudy mix of water and suspended particles. We can also create a mixture that is in between a suspension and homogeneous solution. This will usually form because the particle size is larger than the ions or small molecules, but smaller than the particles in a suspension. Such a solution is called a colloid or a colloidal dispersion. To illustrate the difference between a solution, a colloid, and a suspension, let's look at salt water, milk, and mud. The difference in particle size is what determines the different characteristics of this mixture. The particles in a colloid are large enough to scatter light, which is a phenomenon called the Tyndall effect. This is why colloidal mixture will appear cloudy or opaque. The white particles in the air are visible inside the beams of bright light, which is what illuminates big event spotlights. Colloids like fog and smoke are what make these beams so bright due to their scattering ability. Some colloidal particles consist of hundreds of or thousands of molecules, but some are large molecules, like a protein. And when we discuss colloid instead of solid and solvent, we will call the particular compound present in small amounts the dispersive phase, and the substance the particle is dispersed in will be the dispersion medium. The dispersed phase and the dispersion medium can each be of any phase. Smoke is solidly dispersed in gas. Clouds, fogs, and mist involve liquid dispersed in gas. Milk, mayonnaise, and butter involve liquid dispersed in liquid. Jellies and shells are liquid dispersed in solids. Foams and whipped cream involve gas dispersed in liquid. So we can see that there are quite a wide variety of colloids. Now that we know what colloids are, let's discuss how they can be prepared. In order to prepare a colloid, we must first produce particles of colloidal dimension, which means they must be above a size that will generate a solution but below a size that will generate a suspension, and then we must distribute these particles throughout a dispersion medium. There are two ways to prepare this particle. The first is by breaking down large particles. This is how many fine pigments are produced. The other way is by combining smaller molecules. This is how clouds form. Water molecules high up in the atmosphere, which gets very cold, are able to condense enough to form tiny droplets that then accrete. If the water droplets become too large to remain in the clouds, we get precipitation, which is what causes rain, sleet, and snow. There are also some solid substances that spontaneously form colloidal systems when mixed with water, like gelatin or starch. This substance contains particles that are already of colloidal size. The water simply disperses them. Another type of colloid is called an emulsion. This occurs when two immiscible liquids are forcibly blended. One liquid will break into colloidal droplets and disperse through the other liquid. This is why all spills in the oceans are hard to clean up. The action from waves causes an emulsion to form. But sometimes emulsion will cause and spread from the other liquid. To combat this tendency, an emulsifying agent can be used. This is a substance that inhibits the coalescence for the dispersed colloid liquid. Milk and mayonnaise are examples of emulsion. Milk is an emulsion of butter in water, with a protein called casein acting emulsion agent, and mayonnaise in an emulsion of oil in vinegar, with egg yolk components acting as the emulsion agent. Sometimes dispersed colloidal particles will bear an electrical charge. In any particular system, all the colloidal particles will have the same charge, which helps keep the particle dispersed since like charges repel one another. We take advantage of the formal charges on colloidal particles to remove them from a variety of mixtures. We can place charged electrodes in a colloidal dispersion, and the charged colloidal particles will mate to one of the electrodes. Once this occurs, the colloidal particles lose their charge and consequently will coagulate as a precipitate. This is how we remove the carbon and dust particles smoke. If smoke passes through sometimes called an electrostatic precipitator, the charged particles in the colloid will be attracted to electrodes. Okay, thanks for watching everyone, and wassalamualaikum warahmatullahi wabarakatuh.